Hey guys, today we have a MacBook Air that's been sent to us from the States to Canada from our TikTok follower Edwin. This machine, it's not turning on, it is charging, we get light on the MagSafe connector, but nothing happens when you prompt to boot. Let's start by removing the bottom panel. Now we're hooking it up to DC power to see what kind of current pull we get. We're getting 30 milliamps. That's not regular current pull for a healthy machine, so we're going to now remove the logic board and take a look under the scope. We're going to start with visual inspection of the main board under the microscope, starting with the top side of the board, looking for obvious points of damage or corrosion or burnt components. Flipping to the back side of the board, everything's looking good so far. SMC area looks great. Right here we identify a damaged area on the board. Looks like two resistors. Looking at the schematics, we identify the components as R7630 and R8185. Due to the nature of the damage that we see, we're not going to take any readings yet. We're going to start by just replacing these two components. Before we replace them, we're just going to clean off the area to get a better look. I'm going to use 99% isopropyl and then blast it with compressed air. Now we are ready to remove the component. We're going to grab our heat station, set it to 380 degrees Celsius and 65 airflow, apply some flux directly to the component. Now we can start heating the board. I'm going to start by heating the general area. Once the area is a good temperature, we can focus heat directly onto the component that we're trying to remove from the board. There it goes. We're also going to pull that other resistor that wasn't looking too good. It's gone. Now we're going to clean the area and see if we have any burnt pads or broken traces. Now we are attempting to expose the pads beneath the damaged resistor that was very corroded and burnt. It looks like we are able to preserve the existing pads in this case. Now that we've exposed the pads, we take some continuity readings to make sure we don't have any broken traces in this area. Everything's checking out good. It looks like we're ready to replace the damaged components. Here we have a donor board with the same resistor. We're going to remove it using hot air and flux and hot air. Going to use the same settings, 380 Celsius and 65 airflow, heating the general area first and then focusing heat directly onto the resistor. We can tell when the solder begins to melt and the resistor is ready to be removed from the board. Now we're going to go back to the customer board and install the component. We're going to start by tinning both pads using flux and our soldering iron with 183 solder. I'm gonna add a little bit more flux and then make 2 nice pillows of solder. And there we go. Now we can use heat to install the resistor onto the board. We can see that the solder is liquefied and we can put the resistor in. We're going to add a little bit more flux and let it flow in nicely here. There it goes. Now we're gonna take a look at the schematics after we clean this area off to see what resistance value the other resistor is. It's 0, so it's essentially a wire. If we wanted to, we could run a little jumper, but we like to use an actual resistor because it looks better. So we'll grab a 0 ohm resistor and install it in place here. Trying to get it off the tweezers. There it goes. Going to use heat again to float this resistor into place. Keeping a close eye to watch the solder melt. We don't want to heat the board for longer than necessary. You can see it there floating into place. Looks good. Now we're going to quickly clean off the area and we're going to test the machine, see if we get fan spin. Now we are plugging it into our DC power supply. We're going to click the output button to output voltages to the machine to see if we get fan spin and also check what kind of amps it draws. We see that it does jump right to 500 milliamps, which is normal. That's what a healthy machine should pull, and the fan is spinning. It looks like this MacBook has been repaired. Now we are going to put the board into the housing and see if we can boot to the login screen. Now that the board is in the housing, we plug it in and wait for it to boot. In this case, we didn't have to test any power rails or anything because there was some obvious damage to components on the main board. Before taking readings and testing resistance values and voltages, I like to replace the obviously damaged components because sometimes that's all you need to do. As you can see, this MacBook is booting up and is fully functional following the repairs.